Another way a tower may vary is in its function. For example, the function of one type of tower is to separate or split components in one boiling range from components in another boiling range. This type of tower can be called a binary tower, a two-product tower, or a splitter tower. For some product specifications, it's necessary to separate light components to control the product's initial boiling point. To meet these specifications, some processes use distillation towers called stabilizers. Another type of tower is called a stripper tower, because it strips lighter components out of the products. However, unlike most other distillation systems, a typical stripper tower system does not condense the overhead product into a liquid. Instead, the overhead product remains as a vapor and is sent for further processing. Some towers are named according to the chemical product that is being separated. For example, a tower that separates propane and lighter components from a feed can be called a depropanizer. The overhead product from a depropanizer contains mostly propane and some lighter components. Components that are heavier than propane end up in the bottoms product. Many distillation towers operate at or near atmospheric pressure. There are some distillation towers, however, that are designed to operate at pressures lower than atmospheric. These types of towers are called vacuum towers. Vacuum tower operation is based on the fact that pressure affects the boiling temperature of a liquid. For example, water boils at 212 degrees Fahrenheit at standard atmospheric pressure, which is 14.7 pounds per square inch, or psi, at sea level. If pressure is decreased to 6 psi, water boils at 170 degrees Fahrenheit. When the pressure inside a tower is reduced, liquids are vaporized at lower temperatures. This process is referred to as vacuum distillation. Now, keep in mind that a vacuum tower does not operate under a perfect vacuum. Vacuum distillation simply means that the pressure in the tower is lower than atmospheric pressure. Vacuum distillation is used for several reasons. First, one or more components in some liquid mixtures may decompose or be damaged at high temperatures. If such a mixture is distilled at high temperatures, an unwanted product may result. A second reason for using vacuum distillation is that running a tower at high temperatures requires more energy or fuel. Operating a tower at lower pressures allows the distillation process to be accomplished at lower temperatures, which requires less energy. A third reason for using vacuum distillation is that a tower that's designed to operate under vacuum, and therefore at a lower temperature, can be constructed of materials that do not have to be specially made for high temperature operation. Structurally, there are two basic differences between a vacuum tower and a tower that operates at atmospheric pressure. We can use this illustration of a vacuum tower system to see what the differences are. For example, a vacuum tower is usually larger in diameter than an atmospheric tower, and the trays are farther apart. These differences are necessary because a vacuum tower generally produces a larger volume of vapors than an atmospheric tower. Another difference is that a vacuum tower has an additional system that creates and maintains a partial vacuum in the tower. The partial vacuum is maintained by either steam jet ejectors or a vacuum pump. These components draw gases out of the tower through the condenser. Azeotropic distillation is a process that is sometimes used with mixtures whose components are difficult to separate. Essentially, an azeotropic mixture behaves as if it were a pure material. The vapor produced by boiling an azeotropic mixture contains the same percentages of components as the original mixture. Even if more heat is applied and all of the mixture vaporizes, the vapor composition remains the same. One way to separate an azeotropic mixture is to use a solvent. The solvent is a substance that, when combined with the azeotropic mixture, allows the separation of components to take place. Another way to separate an azeotropic mixture is to use two distillation towers in a special arrangement. In this topic, we looked at different types of towers commonly used in distillation systems. We also looked at some factors that can affect the physical dimensions of a distillation tower. In addition, we looked at a vacuum distillation and azeotropic distillation. Now try some